I'd like to show you a system that we've developed to be able to take a real driving emissions test from the road and move it into the chassis dyno. So this is a small demo system that we've set up. So what we've done with the first one is we've taken the driver out of the system and we've replaced the driver with something we call the dry con. The dry con essentially is a robotic driver. So when you're driving on a chassis dyno, you don't have a human who's trying to follow a trace anymore. You have a system that will actually play back the pedal signal for the accelerator pedal and the brake. We use the road grade from the chassis dyno to adjust the vehicle speed to what we recorded on the road. This way we get a very exact replication of what was done on the road. The engine is operating in the exact same speed and load conditions, and therefore the engine should be producing very similar exhaust tailpipe emissions that it was producing on the road.
This piece of equipment that you're looking at, manufactured by AVL, is an emissions bench. This particular unit is unique because emission benches tend to be big and large and consume a lot of energy. We call this our AMA SL for slimline. It takes a sample from the raw exhaust, brings it through a pump system, and then into the analyzer. And what you're viewing here on the screen is the software. So here's all the different components, and we can calibrate those analyzers, we can put it in a measure mode, and we can record the data with another computer. Inside of the system, we have our different components in here. So we have some valves up here to control gas flow, because we routinely have to calibrate the system. We might need to route the measurement gas to the particular analyzers. Then we have heated components, because exhaust gas has a lot of water. So we're going to keep that in suspension. So we have heated components here, here, and then all down through the system. All of this system is designed so we can pull a pin, take out a connection here, here, and we can quickly remove the piece of hardware and put a replacement in. So it's a plug-and-play system. Did I mention that it's low energy? So typical benches take somewhere between 20 or 30 to 50 amps of 110 volt power. And this system is running on 20 amps, one circuit. It's universal voltage. Everything inside is 24 volts, so it's safe to operate and work on while it's powered up, which is also unique. And exhaust emissions, with the downsizing of engines today, engines are getting smaller and smaller. When we take the sample out, sometimes it's not going across the after-treatment systems, and so we can't test the full effect of the after-treatment system if we're removing the sample. So this system is designed with low flow, so it's taking a fraction of the sample that previous systems were taking.
We have our AVL 492, which covers our four gases in the form of CO, CO2, NO, and NO2. We also have our exhaust flow meter underneath the device, all mounted together to give you your mass emissions on road. We have a central data acquisition system called our system controller that has software that then controls whatever devices we have on the vehicle in use. It will take control of those devices and bring them all into one file. We have our GPS data as well as our weather data that's all collected. We also have the ability to add additional gas analyzer in the form of a dual channel FID, measuring hydrocarbon, total hydrocarbon as well as methane. We also have the ability to do particle number on the vehicle as well as particle mass on vehicle. We have the ability to do real-time fuel consumption as well. Here we have the ability to take data out on the road, generate a route before we go and drive it that would meet certain speed parameters that we're looking for, verify that that route would meet a certain time requirement, such as the 90 minute to 120 minute for the RDE in Europe, and we can go out and run that route, collect the data, bring it back into the test cell, and replay it wirelessly between the PEMS unit here and the automation that we have within the test cell in the form of Puma and iGen. We also have some of our devices here in regards to particle measurement. We have our smart sampler as well as our AVL APC, which is measuring particle number.